Hey, college algebra students, this is Mrs. Cornell. Thanks for tuning in to this video. I'm going to work through your midterm review worksheet with you, so you'll need to have this printed from your midterm folder in Blackboard and also have your calculator handy so that we can check some of our problems. I'm going to work through these pretty quickly, so feel free to pause and reverse and listen as many times as you feel necessary in order to understand the information. So let's go ahead and get started. The first few problems here deal with complex numbers or imaginary numbers. So our goal is to simplify these problems. So let's begin with number 1. Here we are simply subtracting two complex numbers, and we're going to treat this like we're simply combining like terms. So what we're going to do first is notice that we are subtracting complex numbers, so we need to begin by distributing this negative sign. Dropping the first set of parentheses, we have negative 7 plus 2i, and distributing that negative into the second set of parentheses, we get plus 8 plus 7i. Now we're going to combine the real parts and the imaginary parts. So if I combine negative 7 plus 8, I get 1, and adding 2i to 7i, we end up with plus 9i. So the correct answer for this problem is 1 plus 9i. Notice the directions indicate that all of our answers have to be in standard form. That means the real part has to come first, the imaginary part has to come second. Make sure that you get it in that order. If you haven't noticed already, my math lab marks that wrong if you get it in the wrong order. I will give you partial credit for it on the midterm exam, but for full credit, it needs to be in that standard form. Okay, there's one down. Let's look at number 2. You're going to see that number 2 is a little easier because instead of subtracting complex numbers, we are adding complex numbers. So there's no need for any distributive property here. So we can simply drop that second set of parentheses and then combine like terms, or combine the real parts and the imaginary parts. So notice my real number here is 11, and then I'm going to combine the imaginary parts. Negative 3i plus negative I is negative 4i. Again, do notice that we put the real part first and the imaginary part second. Moving on to a different operation in the next question. We are going from adding and subtracting now to multiplying complex numbers. All we have to do is use our distributive property, and remember that when we see an I squared, we replace it with negative 1. So let's distribute the 3i to each term in parentheses. So 3i times 2 gives us 6i, and 3i times negative 6i gives me negative 18i squared. Now, I see the I squared there, so I'm going to replace it with negative 1. We have 6i minus 18 times negative 1. 18 times negative 1 is positive 18, and we're almost there, except do notice it's not in standard form. That means we need the real part first, the imaginary part second. So we end up with the answer 18 plus 6i. Now here's something that you may not have learned yet as you have progressed through this class, but I definitely want to show you this before you go take your midterm exam. Did you know that you can check this on your calculator? Check out your calculator. Let me clear out what I have here. We can type this problem in exactly as it appears and allow the calculator to check it for us. So I'm going to type in 3i. Notice the I is right here on the bottom above the decimal key. See it down there? So to access it, I have to press my second key and then the decimal. And on my home screen, try it one more time. There it is. I see the I. So I have 3i, open parentheses, 2 minus 6, and then the second key and the decimal again to access the I. Close parentheses, press enter, and check our answer. 18 plus 6i is what the calculator tells us, and woo, we got lucky, 18 plus 6i. So please be aware of that function on your calculator. Of course, on your midterm exam, you'll have to show all of the work that we went through right here for full credit, but do check it with your calculator. If you check it before I check it, maybe you can catch some mistakes. Moving on to problem 4. Be very careful on this problem. It's tempting to simply distribute this exponent, but that won't give us the correct answer. What we're going to do instead is obey that exponent, which is indicating I need to multiply that base by itself twice. When I write it like this, I recognize, oh, this is just a FOIL problem. So let's go through our FOIL process. We have 4 times 4, which is 16. That's our first terms. Let's work on our outside terms. We have 4 times negative 3i, which is negative 12i. Our inside terms, we have negative 3i times 4. That's going to give me another negative 12i. And then finally, for our last terms, we have negative 3i times negative 3i gives us plus 9i squared. On the next step, we need to combine like terms here in the middle, and then recognize this I squared needs to be replaced with a negative 1. So combining like terms, we have negative 24i there in the middle, and replacing that I squared with a negative 1, we have 9 times negative 1. Let's simplify that last term just a bit, calling it a minus 9. Now, to finish up, we need to combine our real parts. 16 minus 9, that's going to give me 7 minus 24i. This one, notice we can also check with our calculator. So we have 7 minus 24i. So let's flip over to our calculator here. I'm going to type in the problem exactly as it's written originally. I'm going to open parentheses here. There we go. 4 minus 3 second decimal to get the I on the screen. Okay, and then close parentheses. To square it, I'm just going to type this x squared button and press enter. It's a little faster than we are, but it gives us the correct answer in standard form, 7 minus 24i. All right, we are on a roll. Let's look at the next question. Now, when you look at this, you're not quite sure what it's asking you to do. How am I going to simplify this? Anytime you are dividing complex numbers, ultimately, you're just rationalizing the denominator. It doesn't really feel like division at all. But we're going to multiply the top and the bottom by the complex conjugate of the denominator. That means I'm going to use the same 2 terms, but a different sign in between. Okay, so I have the 7 and the I, but again, I've changed the sign in the middle. This implies a lot of FOIL, so I'm going to add some parentheses here to sort of guide our brains. Working on foiling the numerator, we have 2 times 7, which is 14. Outside terms, we have 2 times negative I, that gives me negative 2i. Inside terms, 4i times 7 gives me plus 28i. And last, we have minus 4i squared. That's going to require a little simplification on the next step. But let's work on foiling the denominator. The first 2 terms give us a product of 49, 7 times 7. Outside terms, we have minus 7i. Inside terms, plus 7i. And last, minus I squared. Anytime I multiply by the complex conjugate, we're going to see those middle terms cancel out. On the next step, we're going to simplify both the top and the bottom. So in the top, we have 2 complex numbers, 2 imaginary numbers that we need to combine, and an I squared to work on. So we have 14, combining the middle terms, 26i, replacing that I squared with a negative 1. Now if you want to do a shortcut here, the I squared gets replaced with negative 1. Negative 4 times negative 1 gives me a plus 4. Okay, so the I squared will always simply change that sign as a shortcut. Working on the denominator, we have 49. Again, this I squared gets replaced with a negative 1, and a negative 1 is a positive 1. Okay, back to the numerator. Let's combine our real parts. 14 plus 4 gives me 18, and we still have this 26i, and in the denominator we have 50. Now that feels pretty good. We made it pretty far, but don't express your answer this way. Remember, standard form is real part plus imaginary part, and they have to be separate. So, splitting up our fraction, we have 18 over 50 plus 26i over 50. So it's in standard form, but now we need to reduce. So let's see, 18 and 50 are both even numbers. So if I divide 18 by 2, that leaves 9. 50 divided by 2 is 25. So my real part is 9 over 25. Working on a common factor of 2 in that second fraction, 26 divided by 2 is 13. 50 divided by 2 is 25. So my second fraction becomes 13i over 25. Now, the I can either go in the middle of the fraction or on the top. Just be very clear that it's not in the bottom. Okay, let's work on one more problem dealing with complex numbers. Number 6, we have the same operation, and that is division. So our goal is to rationalize the denominator. And to rationalize the denominator, we multiply the top and the bottom by the complex conjugate of the denominator. Again, we're going to have lots of FOIL to carry out, so let's add some parentheses here. Notice in the top, we're not foiling, we are distributing this 7i. So 7i times 5 gives me 35i. 7i times negative 3i is negative 21i squared. In the bottom, we will have to FOIL. So the product of our first two terms there is 25. Outside terms, minus 15i. Inside, plus 15i. Last, minus 9i squared. Let's work on our I squareds here. We'll replace both of those with a negative 1. And observe in the denominator, the 15 i's cancel. So cleaning up the top, we have 35i plus 21. And in the bottom, 25 plus 9. Let's rearrange the top so the real part comes first, imaginary part second, and in the bottom we have 34. Almost there. Remember, we have to split it up into standard form. So we end up with 21 over 34 plus 35i over 34. All right. All right, thanks for listening. We're going to cut off this video here, and in the next video, we'll start with problem 7.